This video will cover step-by-step documentation for the construction of my well-insulated propane tank foundry furnace. The furnace was constructed using novel techniques to achieve a well-refined and reproducible result. With my custom-designed forced air burner, it performs well and easily melts brass on only a few psi of propane gas. Before cutting into the barbecue tank, it must be purged of residual propane gas. This is most easily accomplished by removing the valve and filling the tank with water. Since the tank is now being used as a furnace, it's a prudent decision to strip the original paint and replace it with a high-temperature enamel. The tank has a rounded bottom which must be leveled out before installing a floor. Regular bricks can be crushed into small bits and used as a lightweight, temperature-resistant media for this purpose. I used a pottery kiln shelf for the floor of my furnace. They are an affordable option but can be challenging to procure. Regular soft insulating fire bricks would be a suitable alternative, but may degrade faster than a pottery kiln shelf. A masonry wheel on an angle grinder is effective at removing material to make the shelf fit. Ceramic fibre is a good choice for insulating the furnace lid. It is easy to work with and can be stabilized by spraying on a dilute mixture of regular furnace cement. With the furnace body prepped, it's time to shape the fire bricks. By leveraging the precision afforded by computer-aided design and CNC manufacturing, I created some custom jigs for grinding the fire bricks to a perfect fit. It was a slow process, but worth the effort. I will cover this novel method in greater detail in a future video. The furnace is reassembled for the inaugural test firing. I had experimented with coating the soft fire bricks in dilute furnace cement, but I've since decided that this effort was unnecessary. The fire bricks are a consumable item, and this design allows them to be easily replaced when required. I load the furnace with a small graphite crucible full of scrap brass. A small piece of soft fire brick serves as a plinth. I set the burner to run rich and light the furnace. Airflow can be increased to achieve better combustion efficiency as the furnace warms up. Even though the brass is almost at melting temperature, the outside of the furnace is still cool to the touch. The soft fire bricks do a very good job of insulating the furnace body. The ceramic fibre is also a fairly effective insulator, but the lid is much hotter than the furnace body. The furnace outperformed my expectations. The brass melted very rapidly. The metal became superheated and zinc began boiling out of solution. Although I was unprepared, I decided to pour the metal before the composition of the alloy changed substantially. The brass machines well, but it is full of gaseous inclusions, making it unsuitable for machining functional parts. I'll probably chop it up and recast it in the future. These inclusions were likely caused by my unsteady pouring technique, the excessive temperature of the brass, and a lack of degassing material. Had I been more prepared, I would have added a small quantity of phosphor bronze to the alloy as a degassing agent. This would have likely resolved the issue.